Alrighty. So this is going to be 3.3, and it's called dividing polynomials. Do y'all remember doing long division when you guys were in elementary? There's also the remainder theorem. So we're going to be reviewing long division. We're going to be going into synthetic division. You're going to decide which one's easier, which was harder. Your assignment is going to say, in this one, you have to use long division. Even though using synthetic is going to be easier, you use long. Oh, great. So do you remember having to do like 325 divided by 6? You remember dividing like this? Yes? So you would ask 6 goes into 3, does it? Yeah. No, so there's a 0. So then you do 6 goes into 32, how many times? 5. And then you would multiply 5 times 6 and get 30. And what would you put up here? A subtraction, right? And 32 minus 30 was what? 2. And then you would bring down the 5. 6 goes into 25, 4 times. Very good. You multiply. That was a 24. We subtract. What is this called? Your remainder, right? So my answer was 54 and 1/6 because your remainder goes over your divisor. You remember doing this? So now we're going to do this, but with an x squared, x cubed, x to the 4th. So it's going to get a little bit more challenging, but it's something that you should be able to do because the same rules apply. Same rules apply. So, for example, the first one, example number 1, use long division. So I'm going to move this up all the way. My problem is x squared plus 10x plus 21. All this is divided by x plus 3. And this is the first problem we're doing from this section. All right. So the first question you need to ask yourself is, what do I have here? X squared. And it always deals with the first thing. What times this is going to give me an x squared? X. Now, the x goes here. Why there? Because this is your column for x's. This is where your x squared would go. So you're telling me x times x is what? X squared. X times positive 3 is what? 3x. Now, what do you put up in the front? A subtraction, right? Now, so this problem was originally a positive. Now it's going to become a what? A negative. This one used to be a positive. Now it's going to become a negative also. Because it's like this. You had this here. If I put a negative in front of it, what happens? Negative x squared, negative 3x. This is why they both have to change.
So on the top, would it change to a negative 6 or a negative x?
No, that one stays. This is the only part that changes the inside. So what happens when you have an x squared minus x squared? Cancels. And that's the whole purpose behind it. Those need to cancel and it has to start getting smaller. What is 10x minus 3x? 7x. And then we bring down the 21. So now the question is, and it's always going to be, how do I get this number? How do I get a 7x if I have an x? Times 7, positive or negative? So I have to multiply x times 7, which is 7x, 7 times a positive 3, which is a positive 21. But because I have to add the minus in the front, this becomes a minus, and this now becomes a what? Minus also. So this crosses out, this crosses out. My remainder is 0. So what is my answer? X plus 7 would be your final answer. We're going to do a couple. Huh?
If there is a remainder over.
You would put plus and then the remainder over this whole thing. So, are we okay with it? It wasn't so bad, right? Questions on it? All right, so let's look at B. B is going to be 6x cubed minus x squared minus 5x plus 4. All this divided by 3x minus 2. So let me move this up. So 6x cubed minus x squared minus 5x plus 4 divided by that. So which number am I trying to get first? 6x cubed. So this times what is going to give me a 6x cubed?
2x squared.
2x squared. So would I put this here or here?
The second one.
Here, right? Because this is where the x squares go. So it's like the units place. So you're telling me it's a, what is it going to be? We said 2x squared, because this guy has a squared. That's where your, if this were a square, it goes there. If it would have been something with an x, then you would put it here. So what is 2x squared times 3x? 6x cubed. What is 2x squared times a negative 2x? Minus 4x squared. But they both become what? This becomes a negative, but now this one's going to become a positive. So we forget that because a negative times a negative became a positive. So do the first ones cancel? Yes, perfect. What is negative 1x squared plus a 4x squared? 3x squared. And what do I have to do? Bring down the negative 5x. And now the question is, what times this is going to give me a 3x squared? Just x, right? So positive x. So what is x times 3x? 3x squared. What is x times a negative 2? But then don't forget, if it changes this into a negative and this one into a positive. Do the first two cancel the way they're supposed to? Yes. Negative 5 plus 2 becomes a negative 3x, and we bring down the 4 plus 4, right? Now, what times 3x is going to give me a negative 3x? A negative 1. It has to be negative. And what's a negative 1 times x? Negative 3x. And the negative 1x times a negative 2 is a positive 2. Oops. So it is a positive 2. But because you put the minus, this now becomes a positive, and this now becomes a negative. Do these cancel? Yes. What happens here? What's 4 minus 2? 2. So this guy is your remainder. Now, how do you write the answer? My answer is 2x squared plus x minus 1 plus, because it's a positive, my remainder over 3x minus 2. This would be your answer. You have to put it over your divisor, which is right there. Are we okay? All right. C is going to be a tad different. Any questions on that one? Is it better? Does it make a little bit more sense in the first one? Yes? Okay. So for problem C, it's going to say divide 6x to the 4th plus 5x cubed plus 3x minus 5 by 3x squared minus 2x. So when I write out the division problem for this one, we're going to have to be careful. Why? Are all your degrees in order over there?
Yeah.
We have to the 4th, we have to the 3rd, but is there a to the square?
No.
But we're going to have to put it to the square. But what number are we going to put in front of it? A 0. So when I write this out, it's going to have to be 6x to the 4th plus 5x cubed plus 0x squared plus 3x minus 5. All this is divided by 3x squared minus 2x. So if there is one missing, you have to put it with a 0. You have to. Are we clear there? Yes? Perfect. So what am I looking for first? 6x to the 4th. So this times what is going to give me a 6x to the 4th? And where do I put the 2x? 2x what? 2x squared. Where am I going to put it? On top of the 0. 2x squared. So what is 2x squared times a 3x to the 3x squared? 6x to the 4th. What is 2x times a negative 2x? But then this one becomes a minus and this one becomes a plus. So crosses, this becomes 9x cubed. We bring down the 0x squared. And now I'm trying to find the 9. So 3x squared times what's going to give me 9x cubed? 3x. So 3x goes here. 3x times 3x squared is 9x cubed. 3x times a negative 2x is a x squared. So now this becomes a negative and this one becomes a positive. Crosses 6x squared. We bring down the 3x. And how do I get a 6x squared? 2, just a 2, right? So 2 times 3x squared, 6x squared. 2 times a negative 2x, negative 4x. We do this. This becomes a minus, and this now becomes a, this crosses out. This becomes a 7x, and then we bring down. But we come to this part. Is there anything, we've already reached the what here? The n. So this whole thing is your remainder. So that's why you need to start off by putting it in the right place, because that's how you know, boop, I can't go anymore. It stops right there. So the answer would be 2x squared plus 3x plus 2 plus 7x minus 5 over 3x squared minus 2x. Now, of course, you don't have to write it out because it's going to be multiple choice, but you have to do your work correctly. Questions right now? Are you sure? Okay, so in example number 2, we're going to use synthetic division. It is a lot easier, but it cannot be used every time. It cannot be used every time, but I'm going to tell you when you could use it. But remember, if a problem specifies use long, you use long division. If it says use synthetic division. So for problem A here, it's going to say divide x cubed plus 4x squared minus 5x plus 5 by x minus 3. So for this one, you need to make sure you have everything. I have a third, a squared, a 1, and a constant. So I'm not missing anything, right? So all you have to do is look for your leading coefficients of each term. Who's the leading coefficient to my x cubed?
1.
So I'm going to put down a 1. Leave a little bit of space. Who's my coefficient for x squared?
4.
Put a 4 here. Who's my leading coefficient for x? Who's my coefficient? Oh, who's my constant? 5. Now, whatever they tell you that they're dividing by, I'm going to have to set it equal to 0 and find out what is your x. So if I have to solve that for x, what does it become?
3.
X is 3. So I will do synthetic division. This is like a different way to do it. So that is your divisor. This 3 is the one that we put right there, just in case you're wondering where that came from. Now, the rule is you always bring down the first number, whatever it is, whether it's a 1, a 5, a 10, a negative 20, you bring it down. So there it is. You multiply the numbers that you get down here, you're going to multiply them times the 3. So what is 1 times 3? And that is the number we put here. Both of those are positive, so you must add them, which gives me 7. And what do I do with that 7? Multiply it by 3, and it gives me 21. Negative 5 and a positive 21 becomes 16. A positive 16. And then what is 16 times 3? 48. And 48 and a 5 becomes a 53. I am done. Now, how is this your answer? You always label from right to left. The first number here is going to be your remainder. This is going to be your constant. This is going to be the x, and this is going to be your x squared. So what is my official answer? Plus 7x plus 16 plus 53 over x minus 3.
That's simple.
It is simple, but you can't use it all the time. And I'm going to tell you once, just give me a sec. I'm going to tell you when you can and when you can't. Are we okay? So how about, because it's super simple, you try this one. Divide 5x cubed plus 6x plus 8 by x plus 2. So go ahead and try this one. Set up the numbers where they would belong. I'll do it right now to see if we agree. So what was the number you put, the first one? 5, and then? 0. Did everybody put the 0? Because there was no x squared. And then 6 and 8, which is the number that goes out here? -2. Perfect. Because remember, you set this equal to 0, and this is where the -2 comes from. So what is the first thing I do? Bring down the 5, and then that becomes a -10. That becomes a, this becomes 20. This becomes 26, -52, and a negative, nope, it should 44, yes. So you always label from the back, this is your remainder, constant, x squared. So my answer is 5x squared minus 10x plus 26 minus 44 over x plus 2. If you want to put a plus and put the negative up with the 44, you can. It's not going to be wrong if you do that. Now, look at the divisors for both of these problems. What do they look like? It's just x plus a number or x minus a number, right? Are you guys okay if I scroll up? If we look at this next one, look at your divisor. Was it just x plus a number or x minus a number? No, right? This one, was it just, well, the one over here, was it just x plus a number, x minus a number? No. Now, the first one, could I have done the first one in a synthetic division? Yes, the first one I could have. Do you guys want to do it so you can see how you would get the same answer or not really? No? Yes? Okay, I have some people that say yes. What would be my numbers? 110 and what? 110, 21, and the number inside would be what? -3, right? So we're redoing this next one. So, oh crap, just kidding. So, redoing number 1, right? The first problem we did, which was 110, 21, and the number out here was a what? -3. So what are you supposed to do? Bring down the first one, -3, 7, -21, 0. Remainder, constant x. Wasn't your answer just x plus 7? So if your number is just an x plus or an x minus, that's when you could use synthetic. That's when it's easy to use synthetic. Are we good? Now, okie dokie. The first example is for problems 1 and 2, because I forgot to tell you. So example number 1 is for problems 1 and 2. Example number 2 is for 3, 4, and 5. And I think we're going to stop there today. So you could do those 5 problems because there's still a lot more to do.